So now we are moving on to solving exponential equations, okay? So guys, we already studied the easy cases. If you guys remember, your easy cases was here, okay? Where we were able to make sure that the bases are the same. Once the bases are the same, we can just take the exponents and make them equal and solve normally. But now we are solving to where sometimes it's not possible to make the bases the same. So let's kind of run through the easy cases to kind of jog your memory. So easy can be rewritten as the same base. So base b to the x equals base b to the y if and only if, students, your exponents could be set equal to one another. And we are always going to isolate the base, okay? Write each base as a power of a common base. I mean, the two bases should be exactly the same. Take the exponents only and set them equal to each other and then solve as normal. This is the one that we're going to focus on today, but we will review one of those easy cases today. More difficult case is when we cannot, okay, write the bases the same. So we have some base to a power, let's call it x, equals a. Now, if this is true, then we can rewrite it as a log equation, okay, which we do know how to go from exponential to log. If it's a log equation, it is going to be rewritten as log base a of x, log base b of a equals x. So we will try to isolate the base, students, okay, get it by itself, then write it as a logarithmic form, and then solve using the change of base, okay? So let's review this really quickly. Examples 18 to 22 here, students. Well, that's kind of not true. Looks like 30 to 36, okay? So 30 to 36. Solve, leave the answer in exact form, and use your calculator and round to 3 decimal places. So the first one says 4 to the power of x equals 64 to the power of x minus 5. So 4 to the power of x, now 64, students, is 4 to the third power, and we will copy down the exponent of x minus 5. Power to the power, we are going to multiply those exponents. So 4 to the x equals 4 to the 3 times x is 3x, 3 times negative 5 is negative 15. Now, this is the easy case where the bases are exactly the same. So we will drop the bases and just take your exponent and set them equal to each other. So go ahead and take a minute to solve that for me. Hopefully you guys started with the minus 3x on both sides. That's negative 2x equals negative 15. Divide both sides by negative 2. So x is going to be a positive 15 over 2. This is going to be a good answer to box up. Yes, you could totally write x equals 7.5. Yes, you can write x equals 7.5 because they're all going to be a nice rational number. Okay, so that's a reminder of your easy case. Now let's go on to a more difficult case, and sometimes you just can't make them the same bases. Now we will try to anyway. So 4 is going to allow us to say 2 times 2. So that's 2 squared to the power of x. 64, students, is going to allow us to say 6 times 4, which is going to be 2 times 3. So those are prime numbers. And 4 is 2 times 2. Notice how we cannot just have one number, okay? There's a 3 in here, so that's kind of making this thing really weird. So we can't really make 4 to the power x and 24 the same common base. So we will just going to rewrite it, okay? Now, you can also write 2 squared to the x equals 24, which is 2 to the 2x equals 24. You can go this route, or you can go this route on the bottom, okay? I'll show you both. Now, according to your guidelines here, okay, you now will write a logarithmic form. So a logarithmic form, if we're using the bottom here, we will start with the base of 2. So log base 2 of 24 equals the exponent, which is 2x. Then we will use a change of base formula. So we will have log of 24 equals 2. I'm sorry, log of 24, don't do that. Log of 24 divided by log of 2, my apologies, equals 2x. Then our next step, we are going to divide both sides by 2 or times it by a 1/2. That's really a personal preference, okay? So if we divide both sides by 2 or times it by 1/2, you will get the same answer. So that will allow us to isolate x here, and that's going to say log of 24 divided by 2 times log of 2. This is your exact answer. We will use a calculator and crunch out the number to round to 3 decimal places. Now, if you go and set the original one here, 4 to the x equals 24, you're going to do the same thing. We're going to say, okay, log base 4 of 24 equals x. And then we're just going to use a common log to crunch out the numbers. So x will have log 24 divided by log of 4. This one is okay too. Now I do want to bring up something. Can you guys see here? You have 2 times log of 2 on the bottom. Technically, if you want to rewrite this as a power, students, x equals log of 24 on the numerator divided by log. Remember, this front number here becomes a power. So if you can see that's a power, that's the same thing as log of 24 divided by log of 4. So that's the same thing as we over here, okay? So it doesn't matter how you guys do your math, you are going to get the same exact one correct answer. All right, so now use your calculator and crunch that out for me, students, and round to 3 decimal places. Okay, so I hope you guys all have 2.292. Example 32, 7 to the nth power, students, equals 20. Clearly 7 is already a prime number. There's no possible way that we could make 7 and 20 the same base. So your very first step is going to rewrite this as a log form. So do me a favor and take a minute to rewrite it as a logarithmic form, please. Hopefully you guys all have log base 7 of 20 equals x. Now there isn't much for us to do because x is already isolated. Woot, woot. So we just have to use the change of base. So log of 20 divided by log of 7. And guess what, guys? You could even use natural log of 20 divided by natural log of 7. And that's okay too. You can use either. And you can box up either. Now use your calculator, and yes, you can use either button and get the same exact decimal approximation, which I would like for you to fill it in right there. Okay, so hopefully your calculator is spitting out 1.5. It says, okay, I'm gonna write this 1.5395, students, but since this is a 5, so what you have to be careful here. This is going to turn into a 0 here, a 0, and a 4 here. So I just want you to be careful, okay? So your rounding is going to say 1.540. Okay, we have 4 more questions. It appears that 33 and 34 are similar, except 34 looks a little bit more difficult. So I'm going to work that out with you guys, and then I'll ask you guys to do 33 on your own, okay? So 34 says 100 times 3 to a power of x minus 4. Remember, only the 3 has a power of x minus 4. And then plus 2 minus, I'm sorry, not minus, plus 2 equals a 523. So step number 1, remember, we need to isolate your base. I mean, we want this to be all by itself. So whatever is around it, we have to get rid of all of it. So now we would have 100, students, times 3 to the power x minus 4. equals 523 minus 2 is 521. Now next is we are going to divide both sides by 100. Yes, we are going to divide both sides by 100. And divided by 100 is super easy. We just have to move the decimal over, okay? So 3 to the power of x minus 4. 521 students divide by 100, move the decimal over, so 5.21. And yes, you can have 5.21 because we haven't really solved for x yet. Next, we need to, remember, base 3 and 5.21, we are not going to be able to make it a common log, okay? So, common base, I should say. So we are going to hit it with a log. So rewrite it in log form. So log base 3 of 5.21 equals to x minus 4. We will need to use the change of base, students. So this is going to say log of 5.21 over log of 3, or you can use natural log. Either one is fine, okay? Equals to x minus 4. Next is we are going to add 4 to both sides because our job is to isolate your x variable. And so that's going to give us the exact form. So x is log of 5.21 divided by log of 3 and then add 4 at the very end. This is your exact form. We are going to box this up. Then please take your calculator and crunch out what the decimal approximation first. Do one at a time, okay? So if your calculation skill is not as great, then just do log of 5.21, hit enter, divide by log of 3, hit enter, then add 4. So my calculator is giving me 5.502. So I would like for you right now to take a couple minutes, work out example 33 in your notes, okay, box of your final answer, both the exact form, students, and the decimal approximation. So hopefully you guys have the same answers as I do here, okay? So step number 1, as you can see, we minus 3 to both sides, okay? Step number 2, we have to rewrite it in log form. Since 7 and 56, we cannot rewrite it using a common base. Then step number 3, we are going to use the change of log, change of base. And then lastly, we move the 2 over by adding 2 to both sides, and that will allow us to get the answer. And then crunch it in your calculator to get 4.069. Okay, example 35 and 36 are very similar again, but I'm just going to do one and ask you to do the other, okay? So let's go do example 36. I believe that's a little bit more difficult looking. All right, so 36 says 4 times e, students, to the power of x minus 1 equals 64. Remember, e to the power of x minus 1, that is your base to the power. So we do need to get rid of the 4 by dividing both sides. That will allow us to have e to the x minus 1 equals 64 divided by 4. That's going to give us 16. Then, well, e is about 2.718, which is kind of an irrational number, so we can't really make it the same as your 16 base. So, but we are going to use natural log, okay? Well, if you don't know what natural log is log base e, and we're going to convert that very soon. But so you can start out with writing log base e of 16 equals x minus 1. Change log base e immediately, students, to natural log. So that's going to say natural log of 16, students, equals x minus 1. Then we are going to add 1 to both sides, just like that. And our final answer is going to say x equals natural log of 16 plus 1. And that is going to be our final exact solution. Now use your calculator and just crunch out normally. Hit in natural log of 16 plus 1. And my calculator is going to say about 3.773 and box that up. Now go ahead and give number 35 a chance, okay? I want you to take a couple minutes, write it all out, box up your final exact answer along with your decimal approximation. All right, guys, so hopefully you guys have the same exact answer here as we have. So step number 1, students, rewrite it as a natural log, okay? You can go straight to natural log of 12 equals 3x if now you are comfortable doing that. I'm making this a little skinnier. And then step number 2, there's only 3 times x, so you can divide both sides by 3 or multiply both sides by 1/3. Either way, you can have this as an answer or this as an answer. and your calculator hopefully will spit out 0.828.